So what we have done earlier was that the basic integration, how we have done that, how it was used, in terms of just simple integration. Now what we want to do is actually to look at how integration is being used. So one of the areas for using integration is this. So we are actually going to calculate. We're going to calculate the area under the graph. Now earlier, if you have just a straight line, if it is just a straight line, it's probably quite simple. Now if this has been a straight line, and if you want to find the area of this piece, it will probably just a simple trapezium. That would do. So how do you find area of a trapezium? Okay, half a plus b and then multiply by the height, right? So that's all you have. Okay, so that would actually be quite simple in that sense. But if it is now a curve, then you are not really sure. You're not really sure whether this particular part is actually a straight line. And most likely or not, because it is a curve, it cannot be a straight line. It will always be a curve. Okay? So how do you find the area of this piece? Okay? So what we want to do is actually to cut this up. Okay? So let's just say we begin with cutting just one strip. Now if you just look at this one strip here, now what is the size of this? Now what we wanted to say is actually if somehow we can cut this into an extremely small piece. Okay? We have an extremely good knife. So we can cut this into a very, very small piece, and we say this is probably a delta x. Okay? As we mentioned earlier, the meaning of delta is something that is extremely small. So if we can actually cut this into a very, very small strip, so we call this delta x, and what would be the height of this? So the height of this will actually be just the y. Alright? Okay? So the height, it would actually be the y. Yeah? Because this is when x equals to the delta x. Right? Okay? Because when x equals to delta x, you substitute that delta x in the function, then you get the y. Right? Now, whether this y now is on the left hand side or is it on the right hand side, does it really matter? Not really. Why? Because we say again, the delta x is something extremely small. Now extremely small means whether it is this side or this side, it will roughly be the same. Okay? Now since it is roughly be the same, again we ask, what does this strip look like? Because we say this strip is extremely small, then everything should look flat. If everything should look flat, it looks like a straight line. Yeah? If it is a straight line, then what shape is this? It is a rectangle. Right? Agreed? So it is a rectangle. In a very similar way, this looks like the earth. Because you are so small, so by standing on the earth, you think that the ground is actually flat. But the ground is not flat, because the earth is not flat. The earth is actually round. Okay? So that has a similar idea here. Because you can cut it into a very, very small strip, that's right, it looks like a rectangle. So how do you find the area here? How do you find the area of this one strip? So the area of this one strip, because it is a rectangle, it would just be y times delta x. So the length times breadth, just that. Okay? So now, but because you want to find the area from A to B, under this strip, under this graph. Okay? So how do you use this? So the area right now from A to B would be, you can integrate this of y dx from A to B. Okay? So this is how the derivation of finding out the area under the graph from x equals to A to x equals to B. So this particular section of the graph. Okay? So this is one of the way that we use integration in this part to find the area under the graph from this area to this area, right? So that's why from point A to B. So that's why earlier we had actually worked out how do you find definite integral. Okay, so this is how it is done. All right. So let's say right now you want to find the area of this part. The function of y is x squared. You only want to find out when x equals to 1 to x equals to 2. So that particular part of the area. Okay? So only this part. Alright? And you know that this piece here, this section here, because it is y equal to x squared, it's definitely that this is not a straight line. So you can't just use a trapezium rule here. Okay? Or you can't just use the area of trapezium. So you have to use integration to do this. Okay? Right? So as we say, how to find that area? So the area under the graph would be integrate y dx. Where is it that you want to work out from? You want to work out from x equals to 1 to x equals to 2. Now it's always from the left to the right hand side. And then when you write in the integration, it has to be from the bottom to the top. So the 1 is written underneath and the 2 is written on top. Okay? So how we say it is also integrate of y dx from 1 to 2, bottoms up. Yeah? So it's always like that. Alright? So what was y equal again? Y equals to x squared as it said here. So instead of writing y now, so you're going to write x squared. Okay? So right now, and if you see this, there's only one variable, that is x. So integration of the x squared, and then respect to x. So it's only right that everything must only be in x. So you're going to have the y in there. Yeah? So how do you integrate this? So you put x. Okay, so 2 plus 1, right? So you add 1 to the index, and then you divide by the result of that. Okay? And remember how do you do this? Okay, what should you write? You should write you should turn this into a square bracket. Okay? And then you should transfer the limit of that 1 to 2 to the right hand side. So 1 is underneath, 2 is on top. Okay? So obviously you know 2 plus 1. So this is 1/3 of x cubed from 1 to 2. Alright? So you continue to work this out. So 1/3 of x cubed from 1 to 2. How do you work this out again? Okay, you substitute when x equals to 2. And then minus, you substitute when x equals to 1. Right? What would that be? Okay, 2 cubed is 8, less 1 is 7. And then because it is an area, so it would be unit square.